here. Thank you. That was awesome. Okay. So now, Monica, do you have the next? Okay, awesome. Okay, so now Dr. Hayworth from Auburn University is going to, Scott kind of gave us an overview of what happened during the spill, and Joel's going to kind of take this down to Florida and Alabama. So you can just tell Monica when to advance. She'll be advancing. No, if you want to hold on to it.
No, that's like my hand.
I kind of do that. Okay, and then.
I don't know if I can work under these conditions. Well, this presentation is designed for impact, so sorry about that. Okay, maybe if you turn the lights down in the back just a little bit more. It's okay if it's dark, right? Oh, Prague. That was Prague. So yeah, I'm Joel Hayworth, professor at Auburn University, and some of my colleagues are here. This work that we're going to talk about is collaborative work, okay? Not just with the Auburn researchers, but with other research institutions and agencies. ADEM is here. So, you know, I don't claim all of this for myself, but somehow I got stuck talking about it. So. Okay, and this was fancy too, so it'll do like the thing, right? All right, so Deepwater Horizon is, right? Don't forget that. Lots of people lost their lives, and of course this is a, you know, a bona fide environmental catastrophe. Okay, and it's also a natural experiment. So we didn't ask for this; it was thrust upon us, and as researchers, we're just trying to figure out what the heck this all means as it's going on. So we don't have control over experimental variables, really. And so be nice to us. We're trying to figure it out, but, you know, it's happening while we're trying to figure it out. Some context, okay? This was referred to, the Kuwaiti oil spill. This was actually the retreating Iraqi army lighting the oil fields on fire. Okay, so that's number one. We're number two, okay? We're number two in terms of volume. And you also see in terms of oiling of shorelines and all that, we're pretty high up there. We're number two there too, aren't we? Yeah, okay. And Ixtoc 1, that's on the other side of the Gulf of Mexico, off the Mexican coast. So that's number three. All right. So take a look at this, all right? This comes from some early documentation, but this has actually been updated with more recent literature. So the numbers are reasonably good, and they're also fairly accepted by researchers. But keep in mind, we really have no idea about these divisions, you know, exactly, okay? What's important here is the shoreline impact. So roughly 18% of all the oil that was released ended up on the shoreline somewhere, okay? Go ahead. 314, oh, go back. Now, if you came up to Auburn, you'd see a really nice Olympic-sized pool. 314 of those, that's a lot of oil, okay? Go ahead. So could it happen again? These are GIS data. I downloaded this probably maybe 2 months ago and plotted it up. So this is federal, I think it's Bureau of Ocean Management, whatever they're called now. So that looks pretty scary to me. I like that one long one that goes to Tampa. But look at that. That's impressive. Okay. So here's a NASA satellite image from June 12th, which is right about when oil showed up on our coastline. And you can see the sheen being reflected. That's what you're looking at there. And, you know, that's a pretty impressive looking image. But if you look at it a little closer, and I'm focusing here on the roughly 50 kilometers of Alabama shoreline, and I've changed the colors and things so that you get a better picture, you can see basically where that oil was coming ashore. So that's pretty much what we're going to talk about in this presentation. All right, so most of the oil that impacted the beaches was an emulsion. All right, that's a water and oil emulsion. It's very nasty, very viscous, very sticky, very hard to get rid of. readily forms these tar balls we've been talking about. And so that's the majority of the oil that showed up on the northern Gulf of Mexico shorelines. And the stuff that was stranded on the beaches was fairly simple to remove, okay? This is Operation Deep Clean in Orange Beach and Gulf Shores. And we snuck down there. Dr. Clement and I did our recon work. We got chased off that beach about, what do you think, 10 times, maybe? Anyway, so that was reasonably easy to remove, reasonably, right? Okay. But the stuff offshore is really difficult to remove. It's difficult to find. And this is the height of our technology for submerged oil mat removal right now. So the extent of that long arm excavator, that's pretty much what we can do. And those are good conditions right there, by the way. I mean, that's slick, calm. Okay? Usually it's not like that. All right. So our focus at Auburn has, our little research group has principally been nearshore and beach systems. So that's what we're going to talk about here. And it's really going to just kind of be a summary of, some of the work that, some of the things that we've learned, and then Dr. Clement is going to go into a little bit more detail about the chemistry of this. Right. Yeah. So the questions that we wanted to ask are, where is the oil, and how is it evolving? And when I say evolving, I mean changing, right? So physically changing, chemically changing, and how long will it hang around? How long will it persist? So we heard about the submerged oil mats, and so this oil exists right now, we're fairly certain, as submerged oil mats somewhere. There are locations, and it's hard to imagine that we've found all these things and removed them. Is there anybody here that would kind of disagree with that statement? I don't think so. Okay. But we don't know exactly where they are, right? That's a big part of the problem. Okay. And also they exist as surface residual balls, tar balls, okay? And these are not separate entities that exist apart from one another. I mean, these things are linked together, right? And so it's a dynamic process. You have submerged oil mats that are buried, periodically being exposed, breaking up. You have these tar balls that are rolling around, and they can become buried themselves and kind of act as quasi-tar mats, okay, depending on how they accumulate, and then, be re-exposed and moved around. Really, the only way to remove this stuff is when it gets beached, okay? Okay. So, again, I mean, we're kind of in the realm of hypothesizing, but we're also basing a lot of this on observational data that submerged oil mats are the primary source of SRBs. So this is fairly logical, right? The original source of SRBs, the original source of tar balls, being submerged oil mats. Okay. Locating, yeah, that's all right. Okay. Except you gave away my punchline. Okay, so locating and verifying these submerged oil mats, I already said, very challenging. Okay. And here's a statement that's kind of really a hypothesis at this point, but there's a lot of work being done to investigate this and either refute it if necessary. Okay, but tar balls, from an ecological perspective, form the greatest risk. Right? Go ahead. So here are two suspected SOM locations from stolen data that happened to fall into my hands. No, this was public data, public scat data. Okay, and this is a beach in Alabama, okay, Bon Secours, very close to the refuge. In fact, this may be on the refuge. It's on the refuge. It is on the refuge? Okay. Do you know where this is?
I work there.
But do you know where this is?
Oh, yeah, well, that's Mobile Street right there.
Okay. Can I talk to you after? Okay. Well, there's a lot of curiosity with this data, okay, and I'm glad you're here, so we'll talk about this some more, hopefully, if I can catch you. All right, but, we still have, and there are a lot of locations like this all along Alabama shoreline and also some locations Florida. And as you move, further to the west, obviously the Chandelier Islands, places like that. I mean, you don't even have to look around for that oil. I mean, it's still there, okay? But, so there are these locations that are suspect, right? And the question is, well, are they there or are they not there? Well, it's really super hard to try to find these things, okay? Because what you're trying to do is you're trying to collect a 3 to 6 to 8 foot sand core from a high intensity surf zone, okay? And that sampling technology is extremely hard. And this is a boat that we're building, that we built actually, that has a system that's designed to be left in the surf zone and to collect these sand cores. It's a vibrocore system, kind of an autonomous unit. You can set it down and pull off, okay? And I actually came from Orange Beach yesterday. Actually, I came this morning. Gosh, I was working yesterday over there on this system, and we've just now got it to the point where we can deploy it, okay? So very soon we're going to be setting this thing out, actually collecting these sand cores. And the whole point is are there tar mats in these locations or not? That's what we're trying to find out. So you can see the crane and the A-frame thing there, and that little black thing is vibrocore. But again, these are really hard to get because of the dynamics in the surf zone and the fact that you're dealing with a homogeneous, well-packed sand that's very difficult to core. A couple more looks at that. Close-ups, there's the vibrocore sitting on the deck, and here it is where we're deploying it in Perdido Bay and testing it. Go ahead. Okay, so I made this statement. Okay. And why is that so? Well, we're going to talk about a couple of pieces of information that are linked together that kind of support this hypothesis, and we're still testing a lot of this hypothesis. And one of the pieces of information is that as these tar balls get smaller, they get more difficult to degrade physically, okay? And if you think about these things, when they originate, they're kind of flat and elliptical, right? They've got a long axis and a very short axis. They look like flattened footballs. But as you roll them around, they start to become more spherical, right? And a sphere is a very stable shape in nature, okay? That's why our planet is a sphere, okay? That's why rocks erode to become spheres. That's the same reason in principle. And so as these things get smaller, they become more stable. So the rate of change in size goes down. So if you can imagine, you start with these big tar balls, and as you get smaller and smaller and smaller, they becomes more and more difficult to make them smaller. So that's one piece of information. The second piece of information is that the number of small tar balls is going up over time. So if you just randomly go down to the beach and over time and you collect a scoop from the surf zone, what you'd see is that on average, the number of tar balls that you collected, there'd be less tar balls, we know that, but the ones you did collect would be small. You're not walking down the beach and seeing gigantic chunks of oil anymore, but they're still there in a lot of places. And the critical size for that, what we think, is around 1 to 2 centimeters. So you get down to 1 to 2 centimeters, and now you're in this zone where it's really hard to get small, okay? And you think about this from a recovery perspective, small tar balls that you can't see are very hard to pick up. Right? Remember these guys walking down the beach with the crab nets? Right? I mean, they were scooping up big ones. Go ahead. Look at those little red dots. Every one of those red dots is a little tar ball. Okay? Now, it doesn't look like this every day, but you can still go down there on a day and find these zones. Okay? So they still exist. So again, keep in mind, this is very dynamic. The system is, these tar balls are coming on shore, moving around, going back offshore, degrading, changing shape. But the trends that we're talking about is as they get smaller, they get less difficult, the rate of change in size goes down, okay? Does that make sense, what I'm saying? Okay, go to the next one. Another piece of information is that they're very resistant to weathering. And if you look at this, that's oil. This plot basically is from the day the oil showed up on the beaches to 2014, late 2014. And what you're noticing here is the amount of weathering, which is a measure of this Hope-Hain ratios, and that's a really complicated thing. But the bottom line is that it weathered a whole lot, and that means a lot of the chemicals that were in this oil that were easily removed, naturally, were removed. And then you reach this flat point where the things that are recalcitrant, that don't want to come out of the oil, are still lingering, okay? So they resist weathering of those compounds. Okay? And they're also very resistant. Some of these compounds are very resistant to biochemical degradation. And a lot of these things are easily biodegraded by bacteria, okay? But some of these compounds are not. And here's a very interesting character that's going to show up in another talk. These are the parents and the very bad children of chrysene, okay? And if you look at this from 500 days, these are tar balls, from 500 days to roughly 1,500 days, very little change in the concentration of these particular chemicals, okay? So they resist getting small, they're very difficult to pick up, they resist weathering, and they resist biodegradation of some compounds. And the last piece of information is, we think, that their mobility is constrained. And this just happens to be just a coincidence of nature, okay? In the northern Gulf of Mexico, you have these distinct circulatory zones for sediment movement, all right? And so if you look at this plot, I'll just point right here, from here to here, okay, anything that's below this line, that's sediment longshore current moving to the west, okay? So, and then you reach these zones where the currents reverse, all right? And so that's kind of an isolated circulatory zone is one way to think about that as far as sediment is concerned. So you have these little tar balls that are they don't want to get small, they don't want to degrade, and they're stuck. They're stuck in this washing machine. They're moving around. Now when they're, this is 20 miles of shoreline from here to here. So there's a lot of movement that occurs along that shoreline, but our hypothesis that we're trying to test right now with a lot of this equipment that we just got going is that there are areas where these currents reverse, you get deposition of these small tar balls, and then at some point you resuspend and bring these back into the system, okay? So this is not just a one-shot deal where, the oil came, we picked it up, the bugs ate the rest, and it's over. It looks like this is one of those things that is going to take some time to go away, right? And that's my last slide, okay? Oh, no, it's not. Oh, sorry. No, it's not. I thought I took this one out. All right, that just basically says what I just said, okay? Resist the degradation. Below that particular size, well, I did leave that out. Below that particular size, 1 to 2 centimeters, they're not recoverable, and this mobility is constrained. Okay, so that is my last slide. Thank you.